Behold the mini hab, our first piece of actual hardware. We're doing it! This is cool. Somewhat embarrassingly, I didn't even make it. But I'll get there. Wanted to give a big shout out and huge thank you to Doug Plata in California with the Space Development Network. I met him last year at the Moon Society's Lunar Development Conference, and when I started getting serious about this channel, reached out to him to see if he was interested in doing collaboration, and I've been working with him in the Space Development Network as the Vice President or Director of the Moon-Mars Analog Base. Super excited to be involved with that. And Doug has been awesome. He's down in California. He built this out of plastic and tape and rope and some other things. You'll get to see more of the details inside later on in the video, but I'm going to include Doug's contact info in the description. If any of you guys are interested in doing something similar to what's going on here, Doug would be a great person to contact. Feel free to contact me too if you want to collaborate. I could always use some more help. The Space Development Network is completely a volunteer organization at this point, and he needs people with all sorts of different skill sets, from website design to architecture to engineering to biology and botany and waste management, and there's just all sorts of things that need to be considered. So if any of you are interested, please reach out to him. I will also include a link to the Space Development Network's website. Yeah, hope that's useful to some of you. So are you guys ready to see how the sausage is made? I was going to film the opening portion of this video inside the habitat, but it's freaking hot in there because there's no ventilation except for the air slowly seeping out, and this is like translucent plastic sheeting, so we've got a major greenhouse effect going on. But anyway, excited to show you guys. This has been a fun video, and look forward to more like it in the future. So let's see how it's done. Okay, we're getting ready to fill this thing up. I'm at my parents' place. Thank you to them for letting us use the backyard. So we've got our mini hab all wrapped up there in plastic and such. We're gonna unfurl that, figure out how to get it oriented correctly, and then we've got top of a shop vac here we're going to use to blow air into it. So got my dad and my mom and Jules, doggo, keeping us safe from lizards and such. So we're going to go ahead and get to it. I got the tripod set up over here that I will put this on. And we will be ready to go. So why inflatables? When it comes to establishing a livable base, I can think of essentially 4 approaches. We have aluminum or steel modules similar to what the International Space Station is made of, 3D printed structures using local materials, excavating tunnels or caves and sealing them off, or inflatables. We already have a pretty good idea of how to build rigid modules, but it would take a lot of launches to get any sort of meaningful volume for our inhabitants to live and work in. 3D printing and excavation offer the prospect of creating more and more volume as long as the machines keep operating, but the necessary technology isn't available yet. Only inflatables combine proven technology with a reasonable volume to launch ratio. There's actually an inflatable module developed by Bigelow Aerospace that's attached to the International Space Station right now. Wow, well, it's been almost an hour, and we're still not all the way filled up, but I don't know that we're going to get to, because this is not a perfect process. I think we're just about as good as it gets. Our air in probably equaling our air out. So there you go. 30-foot diameter circular moon base in about an hour that you would almost certainly die in. Not almost certainly, you would die in this if you had it on the moon. But you gotta start somewhere, so there we go. All right, well, I am just leaving Michael's craft store where I went to get some adhesive Velcro strips that are industrial strength, rated at 10 pounds, so that I can use those to hopefully seal up our door to our first little habitat that we've got here. So hopefully that works. I'll be back to the house soon and away we will go. So try it out. Okay, I am on the inside of the mini hab and just barely finished our little task from Michael's, where we were able to get some Velcro for the exterior door here. So that looks like it's keeping things a lot better sealed. Of course, we lost a lot of air while we were doing that, but now it should be filling up nicely. And I'm just here on the inside patching up other little holes where I see them, like that one. Some of the tape has been coming apart in different places, but yeah, this is the first physical hardware lunar base thing that we've done, and this is really cool. So that's the door over there when it we've got the hose from the shop back in here, but see, we've got these little yellow ropes here. The reason that Doug did this is when you have inflatables and you've got air pressure being the thing that is providing your structural integrity, it wants to push out every direction with equal force. And so naturally this plastic is going to want to turn into a sphere. And so we have these yellow ropes everywhere. See, there's like little washers that they're attached to, and then same thing on the ceiling. What that does is makes it so that when it gets filled, it will, you know, not keep expanding like a circle upwards, but will just stay level, and then we'll kind of push more outward. As you can see though, when it was all the way filled up before we did the door, these little sections wanted to start pulling up. I think a good way to like think about how this works is if you've ever slept on an air mattress. They have like these, you know, you fill up the air mattress and it doesn't just have like the plastic on top, the plastic on bottom, and then the walls of the air mattress. It actually has these little like circles, and then it's got kind of like plastic walls on the inside that's bringing it down so that it doesn't, so that plastic is holding it so that it stays level, so your air mattress doesn't turn into a sphere, because spheres are not very good for sleeping on. Hey, Jules, do you want in? Come over here. Okay, doggo, hang on. What do you think, Jules? What do you think about this? Things are looking pretty good. Like how it's shaping up. All right, well, that took longer than I was expecting. I wish we had had the Velcro idea to begin with, but you know how things go. So got it taken down, got some weights on it right now in case that gets windy tonight, and then I think we're gonna try to re-inflate it tomorrow and see how that goes. hopefully it'll go faster now that we've got that Velcro for the front door. But anyway, there's the mini hab. Thanks, Doug. Glad you could help me out with this. So anyway, till next time. Okay, here we are, day 2. Gonna do another time lapse real quick. We've got the Velcro in place on the door, so hopefully it should fill up quicker. We'll see how it goes. So gonna turn on time lapse real quick. Okay, look at this sucker. That thing is all blown up. We're gonna go inside and check it out. Wow, look at this. Here we are in the mini hab. A lot of usable space. Okay, welcome to the mini hab. All blown up. In fact, it's a little overblown up. You can see here, I have this rope. These are supposed to keep the ceiling pulled in. And this was attached into the floor here, but I wasn't paying attention when it got too full and it popped out. But here we are, and as you can see over here is where we've got our front door. We got some double-sided Velcro. This was a new addition that I put in after I got this from Doug and the Space Development Network. But yeah, here we go. This is pretty hot on my feet. We've got some greenhouse effect going on here, I'm sure. So but this is it. So something that's really cool about this is 30 feet in diameter, which just happens to be roughly the same footprint of the Starship that's being developed at SpaceX. And so when you see those videos showing the inside of the engine compartment where they're doing tests and they've got the 3 engines, those would all be like clustered around right here. Makes me realize they're bigger than they look. But anyway, this is exciting stuff. I mean, if this is like the footprint of Starship from SpaceX, and if that thing is going to be taking stuff to the moon, I mean, you're going to have this much space plus more that, you know, it's going to taper off. That payload bay is kind of at the top, and then it, you know, shapes into the nose cone, and that thing is either going to fold up this way or fold out this way to pull things out of the payload bay. And you can fit way more than you can even fit in this space in that. And so it just makes you think, you know, we started out with that tiny little thing, and here we have this huge workable volume. You know, assuming that you could handle all the things like temperature and air pressure and radiation and whatnot, this is something that, you know, an initial crew of maybe 2 to 4 astronauts or something like that could live and work in for a while. You're going to need to do more if you're going to plan on, you know, using the space for creating food and all sorts of different things like that. Anyway, I think that'll wrap it up for this video. It's really hot in here. That greenhouse effect is pretty killer. I'm sweating. And that's where my phone died. So I guess it was really hot in there. That'll do it for this time. This was fun to make. I'm excited. I think I'll do another video. I'm already thinking of some upgrades for this habitat. And then, you know, we'll tinker around with some stuff there and then get a more advanced version at some point. So anyway, I'll catch you guys next time. See ya.